Hello students, you're welcome to chemistry class. Today we'll be starting with question number 9. Which of the following pairs of substances will react further with oxygen to form a higher oxide? Don't forget that we have oxides of non-metals which are mostly acidic or neutral or okay. So when you add oxygen to, the answer here is supposed to be D, because of the fact that you can add oxygen to sulfur, and that's SO2. You can burn it further in oxygen to form SO3. You can balance the equation. If I put 2 here, it's balanced. You can also add more oxygen to nitrogen 2 oxide to form nitrogen 4 oxide. That's a higher oxide. But you can also add oxygen to carbon monoxide to form carbon dioxide, but you can't add oxygen to CO2 to form any other higher oxide. So C is not the answer. B is not the answer. Why? You can add oxygen to NO to form NO2, but you can't add oxygen to water. You can't react with water. Likewise, this is not the answer. So the answer here is D. In the preparation of oxygen by heating potassium triacylchlorate in the presence of this catalyst, only moderate heat is required because the catalyst acts by A. The answer here is D. The reason is the function of the catalyst is to speed up the rate of chemical reaction by lowering the activation energy. And when you say activation energy is the minimum amount of energy, that reactants must overcome for chemical reaction to occur. So when you add catalyst to the breaking down of potassium triacylchlorate, then you don't really require a large amount of energy because catalysts will actually do the work. So let's look at a case study. This is an endothermic reaction. Why? Heat will enter. This is a change in heat from this place to this place. Delta H is positive. I have A plus B as reactant. For example, I have C plus D as my product. From this place to this place is the energy, activation energy, EA. But when you add catalyst, for example, manganese 4 oxide, to this chemical reaction or to the reactant, what happens is that the breaking down of potassium triacylchlorate will be faster. Then it will provide an alternative path. You can see here the energy required for the reaction to occur or for C and D to be formed is now minimal. So we require very little amount of heat because of the fact that the catalyst is actually working. So the answer here is D. Let's look at the next question. Methanoic acid mixes with water in all proportions and has about the same boiling point as water. Which of the following methods would you adopt to obtain pure water from a mixture of sand, water, and methanoic acid? Don't forget from the question, we're told that water and methanoic acid are mixable. They are mixable liquids. And if you want to separate mixable liquids, the best method to use, one of the best methods to use is to distill. When you boil, they evaporate, or when you heat, they evaporate according to their boiling point. Then you can condense them and take them out of the whole process one after the other through a container. But here there's a sand here. That means we need to filter. We need to filter the mixable liquid from the sand using the process of filtration by pouring the whole mixture in a filter paper. The water and methanoic acid, because they are mixable, they pass through the filter paper and go down the container or the beaker, while the sand remains on the filter paper. Then you can take this container out, then you pass it through the filtration process to actually separate water and methanoic acid according to their boiling point. Don't forget, methanoic acid reaches the boiling point before water. It boils at about 78 degrees Celsius or so. Then water boils after that, then it evaporates. So the answer here is neutralization, no. Neutralization, filtration followed by distillation. The answer here is B. You filtrate, then you distill. Number 12, a quantity of electricity liberates 3.6 grams of silver from its salt. What mass of aluminum will be liberated from its salt by the same quantity of electricity? I think it's talking about the second law of Faraday's law of electrolysis, which says that the amount of substance, when it is passed through when electricity is passed through different electrolytes, when the same quantity of electricity is passed through different electrolytes, then the amount of substance, that's number of mole of substance, produced or generated is inversely proportional to the charge. It's inversely proportional to the charge on the ion. So that means we have N1 over N2 equals to Q2 over Q1. Inversely proportional. So let's look for our N1. We are not giving number of mole, we are giving in terms of mass, so we can convert this mass to number of mole. Then we have something like this. Number of mole of silver is 3.6 gram divided by, number of mole of silver is 3.6 gram divided by 108. We are supposed to have 0.033 mole. So here we have 0.033 mole of silver over the number of mole of aluminum is not known. Don't forget, we are looking for the mass. We can convert to mass later. You can say N2 equals to the charge on silver is 1. So the charge on aluminum inversely proportional is 3, while the charge on silver is 1. Don't forget, we have aluminum 3 plus and we have silver plus. Let's cross multiply. We have N2 equals to 0.033 multiplied by 1 divided by 3. 3 here 1, 3 here 11. So this gives us 0.011 mole. So we can convert the number of mole of aluminum, this aluminum, you can say number of mole of aluminum as N2 equals to mass of aluminum over the molar mass of aluminum. Number of mole of aluminum is known to be 0.011 equals to the mass is what we are looking for. Molar mass of aluminum is 27. So if I cross multiply, I will have the mass to be 0.11 multiplied by 27. Then I have approximately, okay, the options are not here, but I can actually multiply through my calculator and get the answer. I'm supposed to have 0.2, okay, 0.297. 0.297 approximately 0.3. So the answer here is 0.3. You can check up the options. We are supposed to have 0.3 there. Thank you very much. We meet in the next class. Goodbye.